Hello, and welcome to part 3 of Hybrid Transmissions, Operation Theory and Diagnosis. I left you on part 2 with a question, and actually a task and a question. I asked you to go watch the next video in line on Canvas, listen to that vehicle, and kind of guess what you think that the fault would be. And I think it's kind of surprising to know that it's a drum roll please, the ignition coil. That's right, the ignition coil. So common misfires on hybrids. Remember we talked about that damper on the transaxle that tried to absorb those oscillations from the internal combustion engine? Well, misfires in general are going to create a very unbalanced engine, right? Because on a four-cylinder engine, you get that power pulse every 180 degrees or so because of four-stroke process, 2 revolutions to complete a full cycle. So you get a power pulse every 180 degrees. When you got a cylinder misfire, there's a big chunk of power missing. So when it hammers back in, it hits the electric motor, magnetic field, rotor, stator combo, doesn't like that. And then the damper's there to smooth that out. Well, it can't handle that much. So the springs collapse, and then you get that banging, rattling noise that is pretty gnarly. So that is that. Pretty crazy. Something to think about. Don't jump to conclusions. Big tech tip. Do not jump to conclusions. Even if you've done it in the past on that exact car, don't assume that. Someone tells you this is what they fixed. Don't assume that. Those will become a good starting points, but don't jump to conclusions or assume things. So moving on to the pop quiz. Name some personal protective equipment, PPE, that we would use when working on these components. So what kind of stuff would you use? Remember from class, PPE wise? High voltage gloves, Cat 3, 1000 volt DMMs, those triangles on the tools, etc. Right? The hook, warning signs. Yeah, that's it. So what rating? Oh, I did see. There you go. I gave away the answer. Should be looking at my screen. What rating specification must your multimeter meet? And that is Cat 3000 volt. How many volts must your safety gloves protect against? 1000 volt. What must you move from your pockets when working on a permanent magnet rotor? Anything that you don't want to get magnetized. Just be careful, okay? And then always follow manufacturer service procedures to remain safe and reduce the chance of breaking parts. Always read it. I got no pride. Just read a service manual. Things change. That's why it's online. So anyway, back to transaxle diagnostic tests. Before we move the transaxle, there are some tests you can do in the vehicle to help pinpoint the fault. Push test. Check shortwave high PID, parameter identification, and phase-to-phase resistance tests, both MG1 and MG2. And then there's insulation test, both MG1 and MG2. Also, you do that on the high voltage cables. At the bottom of this page on Canvas, if you're looking at this through Canvas in my class, you will see a video of me going through the insulation and phase-to-phase resistance testing. So that is where that is. Push test. What is meant by a push test? Well, pushing the hybrid in neutral, as you know, based on how the car is designed on any of these traction motor type hybrids, the drive wheels through the final drive differential are connected to the MG2 rotor. So anytime you're pushing the vehicle, the rotor, MG2 rotor is moving, and that is, of course, geared to the planetary gear set. And then that can, therein lies that if you have a problem with magnetic field, you can have this thumping, moving noise. If it's grinding, that gear set can be bad. So this is something to think about. A preliminary diagnosis. It's nothing I would use to confirm anything, but gives you a general idea of the magnetic field, whether it's even, if it's shorted, etc. Follow that up with the phase-to-phase balance and or insulation testing to get a more dynamic picture of what is going on. The other thing you can look at is the shortwave high PID. This is a Toyota thing. And for purpose of this video, I'm not going to go into too much of what shortwave high is. It's an ambiguous terminology that's been, the nomenclature from Toyota is just kind of out there. No one really knows. No, but we're not going to go into it. But it is a PID you can use. Toyota's been kind of secretive with it, but it gives you an idea of what's going on with the stator before having to disassemble to perform a megameter insulation test. So use the PID under very light throttle. Basically, you don't want to load it while you monitor the PID. And what you're looking for is this graph right here, shortwave high. Basically, it's going to be close to 5 volts. If it constantly drops out near 0, there could be an insulation fault, and then it gives you reason to believe or probable cause to do your live dead live high voltage deactivation, remove the cables, and then do a transaxle test with the insulation megameter or the phase-to-phase balance milliometer. Again, look at that video at the end of this Canvas for an idea of what I'm talking about there. But in general, until then, phase to phase is basically checking that all three of these phases, remember the Y-wound stator, that they're balanced. You don't want to be open, shorted, high resistance, low resistance. All that can create an imbalance. Think about like on your engine. You want all the cylinders to be relatively balanced when producing power. The electric motor is the same thing. A test we use is this phase-to-phase resistance test. So you compare each of the readings across all phases. Compare that to manufacturer specs, which I'll be honest are elusive. You're looking for basically within 5% is my rule of thumb. Again, I wouldn't, if you're at 5.5%, it's not definitive that it's bad. It just gives you an idea of the health of the stator. So basically the DVOM or DMM isn't accurate enough to measure phase to phase. Although the meters read milliohms, they're not accurate down to milliohms. Okay, so you're looking at 0.1 ohms and then that's 100 milliohms, and we're looking at readings that could be down as low as 30 milliohms. So you use a phase-to-phase balanced milliohm tester. So yeah, and I'm going to show you what that looks like. Here it is. Here's the Amp Probe MO100, my preferred milliohm phase-to-phase. At this point, the film in this video, they can be had for about $700, maybe a few bucks less. And it uses this Kelvin method, so it's a 4-wire clip that sends out voltage and then monitors current. And what this does is it eliminates the leads from your reading. Okay, so that's basically what it does. So what happens to resistance as temperature increases? It goes up. So make sure the vehicle's at rest. You don't want to be performing this test right after driving it and let it do a cold soak and then check that stator winding. Also, rule of thumb, any car that comes in that you're working on, hybrids, that maybe don't have a complaint, I would go ahead and spend the time and to do a phase-to-phase balance test on their stator windings just to get a ballpark reference. Again, you don't know what's broken until you know what's good. So if you can get a baseline of multiple cars, categorize it, inventory it, whatever you want to do in your computer, just write it down, make a recording of it. That way you know. I did that all the time as a tech. I would write down known good values on known good cars. It's worth the extra 5-10 minutes, to get this information in your database. So, yep. And then here's one. You can see that picture. There's a stator that's burnt. Big NG2 stator, pretty common that they'll burn out. You can check that ahead of time without having to pull the cover plate off and disassemble it. You will definitely see that in a phase-to-phase and/or insulation test, which we'll go to next. So. Again, I wouldn't be caught up on what the spec is. I'd be looking for balance within 5% is kind of my rule of thumb. So insulation testing is going to check for shorts to ground. So this high voltage cabling and stator wiring cannot touch chassis ground, right? So if it does, it's going to trigger a fault code for insulation breakdown. You need to pull out the megameter to do an adequate test. Your DMM ohm meter is not sufficient enough for this. It needs higher voltage to push it through to check. But your testing procedure is identical to what you learned in 41. You're going to isolate the circuit, hook up the megameter just like you'd hook up an ohm meter, and check for a continuity to ground. The difference is you're going to push a test button, and that's going to send up to 500 volts through the circuit to do an adequate resistance check. So just something to think about. A tool that's needed. So known as a mega ohm meter, insulation, isolation. I've heard all of these things. So it's up to you what you want to call it. Always follow manufacturer service procedures for power and down and disconnecting high voltage circuits, and remember to wait for those capacitors to drain and then perform your live dead live, which won't be in the manufacturer's recommendation, but I highly advise it. Here's two more tools for doing insulation tests. You got your Bosch FSA 050 Megger, my preferred tool. I like it. It has a it's a digital meter that shows us analog graph, which is kind of nice. It gives you a sweeping motion, which you'll see in the video at the end of this canvas. And then of course the Fluke 1587 we had at class. Fluke makes a great meter. I love my Fluke 88 that I had, but this particular meter is kind of a catch-all. It does the insulation testing. It does voltage and ohm reading, but its ammeter is limited to milliamps. So it's kind of and it's all putting everything into one tool, which I'm usually cautious of. I like to break up my tools, so they tend to work better when you break them up for purpose. It costs a little bit more, but if something breaks, you don't have to replace the whole meter. But that can be used. So follow manufacturer testing procedures compared to their desired specs. basically 10 mega ohms. Anything that you come across that's less than 10 mega ohms, that's 10 million ohms, at a 500 volt setting is going to be indicative of a short or insulation breakdown. So you're going to want to definitely look out for that 10 mega ohms and be aware that the meter can't read less than 10K. So if you have a direct short, the Bosch FSA 050 will display 10K when it could be a direct short. Pay attention to your units. And also tech tip, if you see less than 100 mega ohms, start thinking you have a breakdown imminent. Something's happening. So, yep, be aware. So make sure you isolate what you're testing, just like an ohm meter. Nothing there has changed. You recommend to wear protective gloves, but again, that's up to you. If you're not touching anything that you're testing, make sure you're not leaning up against it, influencing that. Or if you have a pacemaker, you're vulnerable. Again, I know I should say always wear gloves when doing this, but moving on. Always wear gloves when doing this. So release the test button before removing the leads to discharge the high voltage in that tool. You do not want to get shocked with this, even though it's low amperage. If you're vulnerable, pacemaker, etc., or wet, it could have some less than desirable consequences. So, but before replace parts, ask why did it fail. Don't be a parts changer, you're a technician. So this is the difference between an experienced tech and a beginner. Don't just pop a new part in and move on to the next car. Ask why did this happen. This will get you to fix it right the first time that dealers love to throw out to their customers. Okay, if you're replacing a faulty part, it'll break again, come back, blame you, fix it right the first time, scores go down, and the customer satisfaction surveys go down, the dealership gets dinged. No, nobody wins. So make sure you find out why it failed. So find the root cause. If the stator windings are open or shorted and look burnt, ask why again. Back to why did it fail? I like to use the saying symptom to system component to cause. So the symptoms from the customer, you find the system the fault is, that will lead you to the component, and then to finish it off, you find the cause and then verify that all is well. So make sure that you verified it. Always test, don't guess. All right, just do your job thoroughly. So if your diagnosis requires you to remove or replace the MG2 stator or rotor, you can do this in the vehicle. Contrary to popular belief, it is iffy. There are videos on the YouTube's interwebs that you can look up, but you can do this in the vehicle. Just be highly cautious of that magnetic field and that permanent magnet on the MG2 rotor. So follow manufacturer procedures as best you can. Use special tools. But if it's MG1, you got to pull the transaxle. That's got to be split. So that's in there a whole lot deeper. But you look at this picture, you can see that burnt winding. You'll see that on your insulation tests and your phase, more than likely your phase-to-phase balancing. So use those tools and those tests heavily in your field. You will, it'll save you time before you have to pull apart transaxles, and it does give you a confirmation on whether or not it's good. So little nudge, push test, those two tests, and you look like a star. Combined with your PPE, your gloves, your tooling, and your meter, then you are set, ready to roll, and my work here is done. But as of right now, for this week, we have reached the end. If you have any questions, comments, concerns, complaints, etc., email me. And until then, finish off with that next video on how to do those two tests. I actually walk through doing those on my equipment here in my garage studio. Again, if you have any questions, email me. All right. We'll look forward to next week.